Here's another problem, and this one's going to be a little bit more complicated. It's very important that you know where to start, know the clue to know where to start. This is our goal reaction, and so our whole goal is we want to have two reactions so that if we add them up, we will get this one. The trick is to use this goal reaction for our clues as to how to manipulate these, like what factor do we flip them and so forth. To get our clues, we look at our goal reaction. And I'm just going to start with this sulfur that's a solid. And what I do is I look up here and look for sulfur as a solid. And it's only in one place, and that's good because then I know for sure what I'm going to have to do with that second equation. I need to have, my goal reaction has 1 mole of sulfur as a reactant. This one has sulfur as a reactant, but it's 2 moles. So what I know I need to do to this second reaction is that I need to divide it by 2. In other words, I'm going to take 1/2 of that. Okay, let's go on. Let's look at our next reactant, oxygen. Let's see if it's a good clue. And when I look up here, I see it in 2 places. That's going to make it really hard to figure out what to do with this top reaction. I already know the second one. Now I'm just looking for clues for the second one. I don't want to think that hard. So let's just not use that for a clue. We'll go on to this sulfur dioxide. Again, look all up here for sulfur dioxide. And by the way, you should be looking at the state as well. Sulfur dioxide is a gas. I think this problem is a little hard to look at because you're looking at the SO2 and SO3 and so forth. But anyway, so I have sulfur dioxide as a gas, and I see that it's right here. Okay, so that will give me my clue about what I need to do with that top equation. To get sulfur dioxide as a product and just 1 mole, it means I need to flip this to make it a product, and I also need to divide it by 2. So the way I mark that, the flipping makes it negative, and then I'm going to divide it by 2 so that I'll get 1 mole of sulfur dioxide. Okay, so now I know what I'm going to do to each equation. I'm going to go ahead and rewrite them, doing the flipping and the dividing. So the top equation, forgetting my dividing a lot. Here we go. Okay, and then on the delta H, I'm multiplying this by -1/2, so it'll be a positive, and it'll be a 98 kilojoules. Again, using the add rule, these numbers go to the ones place, so my number there will go to the ones place. Okay, on the second one, I don't have to flip it, I just divide by 2. And again, to get the number here, I'm dividing by 2 because I decided to half this reaction. So it'll still be negative because I didn't flip it. Okay. Now I'm going to add these 2. And sometimes when I get to this point, I kind of do a little bit of a shortcut rather than rewriting it all. What I do, just to make it easy to look at, is I kind of circle all of my reactants, and then I circle all of my products, or outline them here. and then look at it and see what cancels rather than rewrite it all. Let's see. So one thing you might do, and I see where I messed up, is that when you write these equations, make sure they're still balanced. It is so easy to forget, and I put a 2 in there, not remembering to divide that one in 2. So I think it did all the others. Yeah. So this 2 should have gone away. Okay, so then we see what cancels, because I saw that wasn't going to cancel. That's how I knew. This cancels. Nothing else. Now I've got to deal with this oxygen. So I've got a half here, and that will cancel with one of these halves here. Or, yeah, so I'll end up with 2 halves, which is the same thing as 1. So I'll end up with a 1 there. And so let's write what's left. And then again, I'm just adding these numbers, or subtracting in this case, but okay, and then I see, did I get my goal reaction? So I'm comparing this to this, and they do match. So this is my answer.